So today we're talking about inequalities and how to solve them, and we will graph them as well. In order to do this first one, we have 4x is greater than or equal to 24. So to solve it, you're going to treat it like it's a normal algebraic equation. The only problem is when we have to divide or multiply by a negative number. In this case, in order to get x by itself, because that's our whole goal, is to isolate, well, I think all right, isolate our x. So in order to do that, I notice that 4 is multiplying by that x. So I have to do my inverse operations. We'll divide by 4, divide by 4. Now I'm dividing by a positive, so I have no problems. It's just going to end up being treated the same way as every other problem ever. So 4 divided by 4, those guys cancel off. And we are left with x is greater than or equal to 24 divided by 4 gives you 6. If I want to graph this, I'm going to do a very sloppy job of it, but it doesn't have to be pretty. We've got 6, 7, 8, this is 5, 4, 3, and we're saying that x is greater than or equal to, so it's going to be a closed dot, and x is everything greater than or equal to the 6, so we will shade everything greater as well. Then we've got that graph. Okay. If we want to do this one over here, again we want to isolate that x, so or that y. Sorry, talking about a different variable this time. So negative 3 is multiplying by that y, so we're going to divide by negative 3. This is the case where I said that we have the problem when we have multiplying or dividing by negative numbers. We are going to end up having to flip this inequality. So don't ever forget that rule. These negative 3's will still cancel off and you're left with y. Our inequality is going to change from less than to greater than. And 12 divided by negative 3 is going to give us a negative 4. So when we graph this, put my negative 4 here. This will be my negative 5. This is my negative 3, negative 2. And we're saying y is greater than negative 4. So since it cannot be equal to negative 4, we're putting an open circle, and we're shading in everything that's greater as well. Okay. Last two down here, these are two-step. So same idea, we want to isolate this guy first since they're attached. So we're going to do the inverse of the addition here. We're going to subtract 4. And we will end up with negative 2x is greater than 6. Now I need to divide by negative 2 to get that x by itself. And these guys cancel off. I am left with x. I divided by a negative, so that inequality has to switch. 6 divided by a negative 2 gives us a negative 3. And now we can graph it. I'll just put my negative 3 here, negative 2, negative 1, 0, negative 4, negative 5, and negative 6 go down here. We're talking about x is less than negative 3. So since it cannot be equal to, we're putting an open circle to show it cannot be that. And we're shading everything that is less than that negative 3. My last one over here is also two-step. I still want to get this guy by itself. So I'm going to go ahead and do my inverse. Switch back to my red. My inverse of the minus 5, I'm going to add 5. Okay. I will end up with x over 3 greater than or equal to 4. Now, to get my x by itself, I'm going to have to multiply both sides by 3 to get that 3 out of the denominator. These guys will cancel off, and I am left with x is greater than or equal to 12. Put my 12 here, 13, 14, 11, 10. It's not pretty, but it works. And we're talking about x is greater than or equal to 12, so it's going to be a closed circle because it can be equal to it. And we will shade everything that is greater than the 12. And then we're done. Okay, so I know I went through these very quickly, and I know that there's several steps to each one, but they're all doable. And as long as you just remember the one key thing, which is when you are multiplying or dividing by a negative number, then you have to flip that inequality like we did in the 2 up here and we did down here in 3. Okay? Hope this helps. Thank you.